Here we have a problem where you have 500 gallons per minute of a fluid flows through a 12-inch pipe, which later reduces to a 6-inch pipe. We want to know the average velocities in the two pipes. So let's put our given information in first. Our volumetric flow rate is 500 gallons per minute. The first section of our pipe is 12 inches in diameter. The second section of our pipe is 6 inches in diameter. And what you should realize after looking at this for a little bit is that this is basically an equation or a problem that is using the continuity equation, or at least part of the continuity equation. And we are assuming steady incompressible flow, and you can also look at this, and from our knowledge we can also expect the flow to the velocity to be faster in the 6-inch flow, and that comes from this equation for the mass flow rate, where the mass flow rate is equal to the density of the fluid times the linear velocity times the cross-sectional area. Also note that the product of the linear velocity times the cross-sectional area is equal to the volumetric flow rate. And the continuity equation says that for a steady incompressible flow, the mass flow rate at position 1 is going to equal the mass flow rate at position 2. So the first thing that we need to do is we need to know what the average velocity is in the two pipes. And so we're given the volumetric flow rate, we know the size of the two pipes, and so we can just use this part of our equations, the relation between the volumetric flow rate and the linear velocity and cross-sectional area, to solve for that. Let's start with position 1, which is the 12-inch section. So we solve for the cross-sectional area first to get our number there, and then we divide the volumetric flow rate by the cross-sectional area, and working this in SI units, that comes to 0.432 meters per second, and in American engineering that's 1.42 feet per second. We do the same thing for the 6-inch section of pipe. And I've got a little verbiage here that also talks about the fact that because this is steady and compressible flow, the mass flow rate is going to be the same. But we can pretty much just skip to this equation here that talks about the volumetric flow rate in relation to the linear velocity and the cross-sectional area. Solve for the cross-sectional area again, like we did for the first section. And then we can either plug in and solve directly for the linear velocity at position 2, or I'm using the continuity equation to also get the answer. And so if we wanted to, we could write V2 is equal to Q dot 1 divided by A2. We should get the same answer. V2, 1.729. So you can solve the problem either way. It really doesn't matter. You're doing the same thing. We get a linear velocity of 1.73 meters per second, or 5.674 feet per second.